Good day, students. This is topic 1, lesson 9, the final lesson of this topic, and it is going to be on CPCT and proving figures are congruent using rigid motions. So for the last 5 lessons, we've been talking about transformations, and today we're going to be talking about transformations and how that is used when dealing with figures that are congruent. So our learning targets for the day is using rigid motion to transform figures and predict the effect of rigid motions on a given figure. Use the definition of congruence in terms of rigid motions to determine if two figures are congruent. And then lastly, applying that definition of congruence to solve problems and justify steps within the context of a proof. So there are 2 questions we need to ask ourselves. How can we determine whether 2 figures are congruent? Well, if one figure can be obtained from the other by some type of sequence of rigid transformations, then we know that those 2 figures are congruent. The second question we need to ask ourselves is, what can you conclude about 2 figures that are congruent? Well, if the corresponding parts are congruent and the relationships between the figures, such as the distance between the vertices or the angles, are congruent, then we can say for sure that those figures are congruent. Okay, let's look at example 1. It says, use the definition of congruence to decide whether the 2 figures are congruent, and then explain your answer. So as I see here, we have 2 figures, triangle ABC and triangle XYZ. The first question states, the 2 figures appear to be the same or different. Well, looking at these 2 figures, to me, they look like they are the same. They are not 2 different figures, so that is on the right track of these 2 figures being congruent. The second statement says you can map triangle ABC to triangle XYZ by well, if I'm trying to map one figure onto another, then there has to be some type of transformation that takes place. But let's first identify what our pre-image and image is. So they define our pre-image as being triangle ABC and our image being triangle XYZ. And as I can see, if I'm going from ABC to XYZ, I see that there's some type of turn. My orientation has changed. So that tells me that there's some type of rotation to the left. And if I'm going to the left, that is counterclockwise. So let's take 2 points, one from the pre-image and one from the image that are corresponding, and then we can probably determine the pattern. So I'm going to pick point B and point Y to look at. So B tells us it's at 8, 4, and our graph is going by 2's. So we have 8, 4 for B, and then for Y, we have -4, 8. So if I look at my points from my pre-image to my image, we can look at the pattern to see if we can determine if there's a rule that's taking place. So if I look at my pre-image to my image, I already see that my points have been switched. Okay, the 8 is now in the Y position for Y, and my 4 is now in the X position for my Y. I also see that my 4 has now become opposite. My 4 is opposite. So my 4 originally was in the Y position and now it's opposite. So that means that we have a opposite sign for Y here. So if we go back to our rotation notes and determine what rotation this is, if I have 2 points that have been flipped and the opposite of Y is taken, I know that is a rotation of 90 degrees counterclockwise, and that would be about the origin. Okay, so I know that mapping is going 90 degrees counterclockwise. Now, is this a rigid or non-rigid transformation from that maps triangle ABC to triangle XYZ? Well, we know any 90-degree rotation counterclockwise is going to be rigid. So this is a rigid motion that maps these 2 triangles onto each other. So if this is a rigid transformation that's mapping the 2, we know that these 2 figures, in fact, are congruent. Okay, so let's look at example 2. The figures shown are congruent, so they give us that these 2 figures, ABCD, is congruent to JKLM. They want us to find a sequence of rigid motions that maps one figure to the other. And then they want us to give the coordinate notation for the transformations we've used. So let's first identify our pre-image and image. So they tell us that ABCD is our pre-image and JKLM is our image. So the first step, they want us to identify the sequence of rigid motions that maps these two images onto each other. So if I notice from my pre-image to my image, I know that my orientation has changed between the two. So that gives me an indication that there's some type of reflection that takes place first. So if I notice that reflection goes about the y-axis, so I can say my first transformation is a reflection about y-axis, and then followed by, it looks like that figure, once the orientation has been flipped, we're moving in a downward motion. So that means my figure is being slid downward. So that means that I have a translation that follows. So now that we've identified the two transformations that are going to be taking place, they want us to write the coordinate notation. So let's first start out with the reflection. So if you remember from the reflection rules, if we reflect about the y-axis, we know that our x becomes opposite and our y stays the same. For the translation, we're actually going to have to find 2 points that are easily identified in the graph that are corresponding to each other. So as I can see in my pre-image, the point that's actually easily identified in the graph is point D, and point D is at 8, 8. Our graph is going by 2's. And then the point that is corresponding to D would be point M, and point M is here. So first we're going to apply the reflection rule to point D, and let's call that D prime, to get to that first transformation. So remember, X is opposite, and Y, which is 8, stays the same. So that's 8. And that point would be here, and we're calling that D prime. Our next step is to find what that translation rule is to get to point M. So if I'm trying to move from D prime to M, I can move in either direction first, either vertically or horizontally, as long as the translation rule is written appropriately. So remember, our graph is going by 2, so let's go down first. So we got 2, 4, 6, 8, 10. So I'm going down 10 units, and remember, we're going down. That's along the y-axis, so that's -10. And then I'm going to the right 2 units. So because I'm going to the right 2 units, that means I'm moving along the x-axis, and that's going to be +2. So that means my coordinates I have for M is -6, -2. And if we apply that rule that we just stated, for my x, if I added 2, then I would get -6. And then if I subtracted 10 from my y, I would actually get -2. So that tells me that this function rule or this coordinate notation is correct for both of my transformations. Okay, example 3 tells us that triangle STU is congruent to triangle BWX, and they want us to find the given side length or angle measure. So in part A, we're talking about a side length. They ask us to find segment SU. So segment SU is located here. Now, before we can find segment SU, we have to first write what we call a congruency statement, and we're going to do that using our SSS solving method. So our congruency statement says SU, segment SU, is congruent to, and then we have to find the corresponding side that it's congruent to. Well, I see here SU is corresponding to VX, which is located here. So that means that it is corresponding to segment VX. Okay. Now, when two things are congruent, we also know that they are equal. So we can remove the segment notation and just say part SU is equal to part BX. Now in this last step, instead of solving, we're going to substitute. SU stays the same, but we do know the value of BX, and the value of BX is 43 feet. And always remember to include the units if they are given. So that tells us that because these two figures are congruent to each other, SU is going to correspond to the same value as VX, which is 43 feet. Now let's look at part B. We're going to do the same thing in writing out our congruency statement. Here they want us to find the measure of angle S. So angle S, we know, is congruent to, and if we look at our picture, angle S is here. Angle S corresponds to angle B, which is here. So I can say angle S is congruent to angle B. And now, if we know that two angles are congruent, we also know that the measures of those angles are also equal. So I can rewrite this as the measure of angle S equals the measure of angle B. So now that we know that these two angles are equal, I can now just substitute in what that response would be. So the measure of angle S equals whatever the measure of angle B is, and we see that it is 38 degrees. And here, ladies and gentlemen, is our answer. Remember to include your units. 38 degrees is not only representing the measure of angle B, but it's also representing the measure of angle X because these two triangles are congruent. Okay, example 4, similarly to what we had in example 3, they're telling us that these two triangles are congruent. So triangle ABC is congruent to triangle DEF. And once again, we have to find the given side length or angle measure. So part A and B now include expressions instead of just numbers, numerical values. So we're going to do the same method that we did in the first example for example 3 as we're going to do for example 4. We're going to use our SSS solving method. So they want us here to find the measure of line segment AB. So AB we have is here, and the corresponding side for AB in triangle DEF would be here, DE. So once again, we're going to write our congruency statement. We say that segment AB is congruent to segment DE. And therefore, we can write our equality statement in saying that AB equals DE. And then we can just solve now and substitute those values in. So here we have AB as being 3x plus 8 and D equaling 5x. And here we're just going to simply solve for x. So that means I'm going to bring my 3x on the other side by subtracting it to both sides. So we have 8 equaling 2x, and then I'm going to divide both sides by 2. So we have x equaling 4, but remember it tells us to find the side length. So we're trying to find the side length of AB. So now we're going to take this for x equaling 4 and plug it back into what the measure of AB is. So remember AB was 3x plus 8, so we're just going to substitute that 4 for x into that expression. So AB equals 3 times 4 gives us 12 plus 8. So AB equals 20. And remember, do not forget the units. That would be inches. So here we have AB at 20 inches. Now we're going to do the same thing for part B. This time we're dealing with the measure of angles. So once again, we're going to write our congruency statement. We have the measure of angle D, and angle D is right here. We know that is corresponding to angle A, which is right here. So we can continue with our congruency statement that, well, hold up, ladies and gentlemen. We don't need the measure yet because we're writing a congruency statement. So angle D is congruent to angle A. In the second step, we can write the measure of angle D. We know is equal to the measure of angle A. And now we just substitute and solve. So what is the measure of angle D? Well, we see here it is 6y plus 2. And the measure of angle A we see is 5y plus 11. So here now we're just going to go ahead and solve for y. So I subtract 5y from both sides. That leaves me with y plus 2 equals 11. And then I subtract my 2 on both sides. So that leaves me with y equals 9. And remember, we're trying to find the measure of angle D. So the measure of angle D, remember, was 6y plus 2. We're just going to go ahead and replace that y with 9 plus 2. And we know 6 times 9 gives us 54 plus 2. So the measure of angle D, 54 plus 2, gives me 56 degrees. So I know for sure that this is my answer of 56 degrees. Now, what if we wanted to check our responses? What if we wanted to check our responses? So for A, B, we see is 20 inches, right? Now remember, AB corresponded with DE. DE is here. If I plug in X, which was 4, DE would also be 20 inches. So we see for sure that this answer is correct because we have the corresponding parts that are equal to each other. And then the measure of angle D corresponds to angle A. And if I replaced Y, what would I have? 5 times 9 plus 11. We know 5 times 9 is 45, and 45 plus 11, that gives me 56 degrees. We can see here for sure that our answers match up. Okay, example 5, they want us to write a proof. So they give us already that these two quadrilaterals, JKLM, are congruent. So JKLM and NPQR, they're congruent figures. They also identify two angles that are congruent. They tell us that angle J is congruent to angle K. So it looks like the base angles of this trapezoid is congruent. Then they want us to prove that angle J from our first figure is congruent to angle P in our second figure. As you can see, I have my little properties of congruence cheat sheet at the bottom. So that gives us an indication that we're going to be using one or more of these responses. So let's go through our proof. They've already filled in two of the reasons for us. They have that the statement that JKLM is congruent to NPQR is given, and we can see that here. And then they give us that angle J is congruent to angle K, and we can see that's also given here in our statement. Now the next statement that they give us is that K is congruent to angle P. So K here is congruent to angle P. Well, if I notice in both of my figures, K here is corresponding to P here. And remember, the definition of congruency means that if I have two figures that are congruent, then its parts are congruent. And so how can I identify this? Well, there is an acronym that we use that's called CPCTC. And what does that acronym stand for? Well, it stands for corresponding parts of congruent figures are congruent. So anytime you have congruent figures, their parts are also congruent. Corresponding parts of congruent figures are congruent. So if they're telling me that K is congruent to angle P, then that tells me that all the other corresponding parts of that figure is also congruent. Now we get to the meat and potatoes. It tells me that we need to prove that angle J is also equal to angle P. Well, let's think about this statement. If angle J is congruent to angle K and angle K is congruent to angle P, sorry guys, angle P, then what can we conclude? Well, I have two statements here that share the same parts. Two statements, angle J congruent to angle K, and the statement angle K congruent to angle P sharing the part of angle K. Well, if I go down here to my little cheat sheet, what property of congruence can I use where I see that if I have two statements that share a part, that I can have another statement created? Well, if you notice here, in the transitive property of congruence, they have two statements where both of them share a part. Well, if that's the case, if both of these statements share a part, then that means the two outside parts have to also be congruent. Then I can say angle J is congruent to angle P. And these are the two outside parts that I'm talking about, angle J and angle P. So because angle J and angle P share a common part that they're congruent to, it also makes these two parts, angle J and angle P, also congruent, and they are congruent under the transitive property of congruence. And ladies and gentlemen, that is the end of this proof. So we've just finished lesson 9 and our 5 examples. Please make sure that you're going to your warm-up activity in your OneNote class folder and completing your vocabulary. Make sure you're watching those videos as well to assist you with your lesson. Have a great day, guys, and I'll see you in class.